Hello students, in this video we are going to start exercise 1.1 of chapter 1 Relations and Functions of class 12. So we have already learned different types of relations. So reflexive relations, symmetric relations and transitive relations. So we will be solving questions related to these relations. So let's just revise them. See, if I have any set A, so elements are 1, 2, 3. So reflexive relation means in that relation I should have duplets like 1, 1, 2, 2, 3, 3. So this type of relation is known as reflexive relation. So all the elements should have duplets here. Then symmetric means if I have 2, 1, I should have 1, 2 also. If I have 3, 1, I should have 1, 3 also. If I have 2, 3, I should have 3, 2 also. So like this, I should have ordered pair. These type of ordered pair should be there. Then the relation is symmetric relation. Then transitive relation. In transitive relation, I should have ordered pairs like this. If I have 1, 2 and 2, 3, then I should have 1, 3 also. See this in detail I have explained in my previous video also. Link I have shared in the description in detail. If you want to learn, you can just go through that video before starting exercise. So let's start exercise. In first question, it's given determine whether each of the following relations are reflexive, symmetric and transitive. So we just have to check. So first one, it's given to us. So relation is already defined now. Relation are in the set A. So A set is given to us. So it has elements like 1, 2, 3 up to 13 and 14. So relation is defined by, it has x, y such that 3x minus y is equals to 0. Okay, so let's check now. First of all, I have to write the relation in roster form. That means all the elements I should write. Then only I will be able to check whether the given relation is reflexive, symmetric or transitive. Okay, so let's write ordered pair. So here one thing I will tell you. So 3x minus y, what does it mean? It actually means 3x is equals to y, or y is equals to 3x you can write if I shift y to other side. So this type of ordered pairs I have to find. See, if 3 times of x is equals to y, suppose if x is 1, then what will be the value of y? 3. If x is 2, then what will be the, see, I'm just substituting the value here. So from there I'm just getting the ordered pairs. See, if x is 1, so if I'm writing 3 into 1 is equals to y, so y's value is 3. So that's what I've written. So first element is x and second element is y if we have to write ordered pair. Now if x is equals to 2, see, x can have values 1 to 14. X can have values 1 to 14, and you have to remember one thing. See, these elements we are getting actually from the Cartesian product of A with itself. So these elements we are getting from A cross A. So if x is 2, so 3 into 2 is y. So that's 6. If x is equals to 3, then what will be the value of y? Y will be 9. If x is equals to 4, then 4 into 4, then it is equals to 16. Okay, but you have to see here 16. See, A cross A means when I am writing the ordered pair, first element should also be present in set A, second element should also be present in set A. If I write here 16, because 4 times 4, 4 times 4 is what? 1 second, here it is 4 times 3. Okay, so this will be there here. 4 into 3 is 12. So here we will get ordered pair 4, 12. With 5 if I do, see, 5 into 3 is what? 15. 5 into 3 is 15. See, 15 doesn't belongs to this set, because the set has only elements till 14. So 15 doesn't belongs to this. So that's why I will not get this ordered pair 5 comma 15. So see, this A should also belongs to, this A should belongs to A, and B should also belongs to A. See, first element should belongs to first set, second element should belongs to second set. Now here both the sets are A only, so that's why these both elements should belongs to A. So 15 doesn't belongs to A. So that means this ordered pair will not come in this relation. Okay, so I have written all the possible values. So relation will have these ordered pairs 4 comma 12. So this is the relation in roster form I have written. In set builder form it was given to us. I have just written all the elements for better understanding of the types of relation now. So I have to check. Let's check for reflexive first of all. Reflexive. Reflexive, I told you duplet should be there. From RD I told you to remember. So duplet should be there. So that means all the 14 elements. I should have 1 comma 1. I should have 2 comma 2. I should have 3 comma 3. Continuing like this, I should have 14 comma 14 as well. So you can see all these elements does not belong to this relation. All these elements does not belongs to this relation, which implies R is not reflexive. So R is not reflexive. Then now we have to check for the symmetric. One second, I'll just use another one. Yes, so I have to use check for symmetric. So R I can write. Okay, so let's do here itself. So first one is not reflexive. Now for symmetric, now for these elements, symmetric, I told you symmetry should be there. If I have 1, 3, I should have, see these elements are already present. I should have 3, 1. I should have 6, 2. See there, opposite I am doing. So 1, 3's opposite will be 3, like symmetrical elements. 3, 1 should be there, 6, 2 should be there, 9, 3 should be there. Then 12, 4 should be there. So, but if we see this relation, we can see here all these elements again does not belongs to this relation. So here we can say this relation is not symmetric. This relation is not symmetric. So first one here I'll write. So it is not reflexive. It is not symmetric. Now we have to check for transitive. Okay, I have just cleared this. Once again, I will have to write. So R 1, 3, then 2, 6, 3, 9, and 4, 12. Okay, so these are the elements. So now we will see here. See, I have to check these type of elements. I have 1, 3, I have 3, 9. See, with 3, this first ordered pair is ending and this one is starting with this one. Okay, so if I have this one, if I have 1, 3 and if I have 3, 9, to make it transitive, I should have 1, 9 also. I should have 1, 9 also. So first and last should also make an ordered pair. But we can see here 1, 9 does not belongs to this relation. 1, comma 9 does not belongs to this relation. So here we can conclude that this relation is not transitive also. So first thing what you have to do, you have to write the relation in roster form. Then easily you will be able to decide whether the given relation is reflexive, symmetric or transitive. Okay, let's do second one now. This is question number first. So subpart we have done. Subpart first we have done. Now let's do second one now. So subpart second. Question number 1 but part second. Now what is given to us? Relation R in the set n of natural numbers. So in previous question From A, we had to make relation from set A. So now in this question, we have to make relation from the set of natural numbers. So what's the relation given to us? R is equals to xy such that y is equals to x plus 5. Y is equals to x plus 5, and there again one condition is given to us, x is less than 4. X is less than 4. So that means if I write the relation, see whenever you are writing relation, see x value we have to write first. So x value is less than 4. So what will be the possible natural numbers? Possible natural numbers, in natural number starts from 1, right? So 1, 2, 3. 4 we cannot take because here equality is not there. So they have clearly mentioned here the value of x we have to take less than 4. So that means I can take the value of x as 1. I can take the value of x as 2. I can take the value of x as 3. So only 3 elements in this relation I'll get. Now y is equals to x plus 5. So with the help of this one, I will be getting y's value. So x plus 5. So what is x here? X is 1. So first elements are x. So x plus 5. Y is x plus 5. So first of all, first x is 1. So 1 plus 5. 1 plus 5 is what? 6. Then second is 2. 2 plus 5, x value I am just substituting here. 2 plus 5 is 7. Then 3, 3 plus 5 is 8. Yes, I can write 1, 6. I can write 2, 7. And I can write 3, 8. Why these relations are acceptable? Because y's value they haven't written, it should be less than 4. Y's value, they have only mentioned one thing, that the value of y, they should belongs to natural number, right? And 6, 7 and 8, 6, 7 and 8, these values belongs to natural numbers. So these are the possible ordered pairs for this relation, because they have restricted x value as less than 4. So less than 4 from set of natural numbers we have to take. So that is only 1, 2 and 3. Now let's check. See, first of all, let's check for reflexive. So reflexive means duplet should be there. If 1 is there, 1 comma 1 should be there. If 2 is there, 2 comma 2 should be there. If 3 is there, 3 comma 3 also should be there, because x value, the possible values of x is 1, 2 and 3. So that means I should have these 3 values, but all these 3 ordered pairs does not belongs to the given relation. So that means again this relation is not reflexive. This relation is not reflexive. So we can write here not reflexive. Let's check for symmetric now. Symmetric also we can see, if 1, 6 is there, 6, 1 should be there. If 2, 7 is there, 7, 2 should also be there. They're symmetric ordered pairs I am writing. So 3, 8 is there, 8, 3 should also be there. But all these values also doesn't belongs to this relation. All these values, so they are symmetric elements we have to see. Symmetric ordered pairs. 6, 1 symmetric ordered pair is 1, 6 is 6, 1. 2, 7 is 7, 2, 3, 8, symmetric ordered pair is 8, 3. So all the 3 ordered pairs doesn't belongs to R, which means the given relation is not symmetric. So it's not reflexive and not symmetric. Let's check for transitive now. So this is the first one, this is second one, and this is third one, transitive. See transitive now you can see here. See I have these ordered pairs, 1 comma 6, 2 comma 7 and 3 comma 8. Here you can see these elements and these elements, they are not at all matching, right? For transitive, I hope you remember, if I have a comma b and b comma c, then I should have a comma c as well. So this type of ordered pairs does not belongs to this relation. See, all ordered pairs are entirely different. So these elements are not at all matching, right? So this means this relation is not transitive. This is not transitive. Let's do now third one. So third one is again question number first, but third part. Third part of question number 1. Relation R in the set A. So set A is given to us. We can write it down. That means from this set we have to get the ordered pairs when we will do A cross A. When we will do A cross A, we will get so many ordered pairs. So from there only, because we have already done what is relation. Relation is a subset of ordered pairs. Okay, so what is first of all set A? 1, 2, 3, 4, 5, 6. Now relation is given to us R equals to xy. Xy such that y is divisible by x. Y is divisible by x. So first of all, we'll write the relation in roster form. So R is equals to, so xy such that y is divisible by x. Now we can see here, I will 1 comma 1 is acceptable here. First of all, let's check for symmetric. If we write, there will be so many elements. So all elements we can write for one. With 1, all the elements is we know, because if we write 1 here, 1 is divisible by all the elements. So this will be 1, 2 also will be there, 1, 3 will also be there, then 1, 4 is also there, 1, 5 is also there, 1, 6 is also there. See, it says y is divisible by x. Y is divisible by, see, 1 is divisible by 1, 2 is divisible by 1, 3 is divisible by 1, 4 is divisible by 1, 5 is also divisible by 1, 6 is also divisible by 1. Now let's see with 2. So 2, 2 is divisible by 2. Then we can write 2, 3 is not possible. Then 2, 4. 2 is divisible by, 4 is divisible by 2 here, because y is divisible by x. Then we will have 2, 6 also. 2, 5 is not possible. So 2, 6. I am just writing all the possible ordered pairs I am writing first, so that it will be easy for us to decide. So 2 comma 6 is also possible here. Then next one we can see here with 3. So 1, 3 we have already written, 2 and 3 not possible. Then 3 and 6, because 6 is divisible by 3. 4 we can see here, with 4 it's not possible. Then 5 also not possible, 6 also no. So these are all the possible ordered pairs which are satisfying this relation that y is divisible by x. So with according to this relation, I have written the ordered pairs. Now first of all, let's check. See, a few I have missed. 2 comma 3. See, 3 comma 3 also, because 3 is divisible by itself. We know that. Same way 4 comma 4 is also there, because 4 is divisible by itself. 5 comma 5 is also there, because it's divisible. 5 is divisible by itself. Same way 6 comma 6 is also there, because all these, every number is divisible by itself, right? So now all the possible ordered pairs I have written which satisfies this condition that y is divisible by x. Let's check first of all reflexive relation. So reflexive means for all the elements I should have duplets. So you can see here I have 1 comma 1, I have 2 comma 2, I have 3 comma 3 also, I have 4 comma 4 also, 5 comma 5 is also there, 6 comma 6 is also there. So all the duplets are there for all elements, for all A. Here I have for all A belongs to capital A. For all small a means all the elements. So that means this relation is reflexive. This relation is reflexive. Okay, now let's check symmetric. For symmetric, we'll check few elements. See, 1 comma 2 is there. For all I have to check. So 1 comma 2 is there. I don't have 2 comma 1. I don't have 2 comma 1. I don't have 3 comma 1. I don't have 4 comma 1. I don't have 5 comma 1. So I don't have 6 comma 1. I don't have, because these will not satisfy also. So that means, see, for all the ordered pairs, their symmetric ordered pair should be there. So 2 comma 4 symmetric ordered pair, 4 comma 2, that also is not there. So that means this relation is not symmetric. This relation is not symmetric. See, I should have these elements. I should have 2 comma 1, 3 comma 1 for all these symmetric ordered pairs which are not there in this relation. So these type of ordered pairs does not belongs to this relation. So that's why this is not symmetric. Now let's check transitive relations. So for transitive, we will have to see if I have, see from here, I'll just clear this unwanted things here. Okay, we'll see. I have 1 comma 1. See, this is ending with 1. This is starting from 1. So I should have 1 comma 2. I should have 1 comma 2. So 1 comma 2 is already here. Okay, now we have to check another one which is ending with same and the other one is starting with same. Yes. So I have this one. You can see I will just write it here so that, see, I have here 1 comma 1 and 1 comma 2. This is like AB and this is like BC. So A and B and B and C, because this is ending at 1, this is starting at 1. So AC I have. AC what it will be? 1 comma 2. So that you can see it's present in the set. Okay, so in set we don't write elements 2 times. So repetition of elements we don't do. So here itself you have to understand. So this is there. Okay, so it is satisfying. Now you have to check if something is ending with 3. This one. So I have, so this type of ordered pairs we just have to check. So I can see here I have 1 comma 3 and I have 3 comma 3. Same way, see, this is ending with 3, this is starting with 3, so I should have 1 comma 3. So this is already present. Now with 4 I have to see. So for these type of all elements I have to check. This type of all elements I have to check. So this I have checked, this I have checked, this also I have checked, and this also we have checked. Now you have to see if anything is starting from 4. Yes, this one. So 1 comma 4 is there, this is 4 comma 4. So 1 comma 4, 4 comma 4. For this also, see, this is ending with 4, this is starting with 4. So 1 comma 4 is also present here. So this one also we have checked. So if anything is starting from 5, see, 1 comma 5, 5 comma 5. So again it will give us 1 5, same way. So this is also there. Same with 1 comma 6 and 6 comma 6. Again this is AB, this is BC. So again AC will be 1 comma 6. Okay, so this one is there. Then 2 comma 2, this one. So 2 comma 4 again. So this is also satisfying. 2 comma 6. Anything is starting with this one, 6. Yes. So these two are also satisfying. So 3 comma 6 and 6 comma 6. So 3 comma 6. So basically all the elements you can see, they are satisfying the condition of transitive. Transitive condition, I'll just remind you, if we have A comma B and B comma C, then we should have A comma C. So we have checked for all the elements. For all the elements, this condition is satisfied. That means this relation is transitive also. So this relation is reflexive and transitive but not symmetric. Okay, so if you write the ordered pairs, so it will be very easy for you to figure out. Let's do the fourth part. See, in fourth part, this is first question's fourth part. Relation R in the set Z of all the integers. Now from Z I have to choose. So R is equals to XY. So this is the relation given to us. R is equals to X comma Y such that X minus Y is an integer. So X minus Y is an integer. See, integer is an infinite set. So we know this. So with certain examples only we can figure out all ordered pairs. Practically it is impossible. So let's check for first of all symmetric. So if I am taking any integer, see, if I do the subtraction of X and Y, so some random integers I'll take. See, if I take any integer 1 if I am taking its duplet, so its subtraction will give us 0. 0 is an integer. If I am taking minus 1 and minus 1, subtraction will give us again 0. See, x minus y, if we subtract, mostly every time we will be getting 0 only. Because if you are subtract, duplet means what? X and y, they are same. So duplet means same number. So same number, if you are subtracting, what you will basically get? You will get basically 0. See, it will be x comma x, right? So what we will get after their subtraction? After their subtraction, we will get 0. And 0 is what? 0 is an integer. 0 belongs to integer. So which means this relation will be reflexive because it satisfies this condition. See, we will not be able to write all the ordered pairs because this infinite set of integers is infinite set. But if we take any duplet 1 comma 1, 2 comma 2, 10 comma 10, 100 comma 100, 1000 comma 1000, minus 100 comma minus, so if same elements, whenever you subtract, because this relation we have to check, this relation should be satisfied. So whenever you subtract the same like number, you will be always getting 0. 0 belongs to integer, so that means this relation is reflexive. Okay, now let's check for symmetric. Symmetric also, you can see here, if I have AB, and if I have AB, so A minus B, A and B both are integers because we are choosing numbers from integers. So A minus B, if it is giving me their subtraction integer, B minus A will also gives us an integer. So this thing we already know with certain examples. You can, if you want, you can just we can just take few examples. So I'll just write both of these will belongs to integers, A minus B and B minus A also. Not like that, I'll just write, if I take this, so this will be true. For all we know, A minus B, it will belongs to integers, and B minus A will also belongs to integers. If I have 1, 2, if I do their subtraction, 1 minus 2 is minus 1. Minus 1 is integer. If I have 2, 1, 2 minus 1 is 1. So 1 is also integer. So basically, whenever we are going to do the subtraction of the ordered pairs, we will always be getting integers only. So that means this relation is symmetric also. This means this relation is reflexive and symmetric also. Symmetric also. Now transitivity also, if we check, say it will satisfy, because again if I have A comma B and if I have B comma C, then definitely if I have A comma C, it will be satisfied, because see, it from here we know A minus B is integer. From here we know B minus C is also integer. And A minus C, because A is integer, C is integer. So A minus C will also belongs to integers, because difference of two integers will also be integer only. So this means this will be transitive. Again, if you want to understand it with the help of example, I'll take one. Suppose I have 1, 2, here 2, 3, and then 1, 3 will be there. So their difference is what? 1, 2 difference minus 1, it belongs to integer. This is also minus 1, it belongs to integer. This is minus 2, 1 minus A is minus 2, minus 2 also belongs to integers. So that is why, that is how we can see this relation is reflexive, symmetric and transitive as well. Now in next video, I will be doing fifth part of question number first, because fifth part, it has 5 subparts. So in this video, if I do, it will become too lengthy, which I don't want to do. So here I have started exercise 1.1 and question number 1's 4 parts I have done. Fifth part I am going to do in next video because it has 5 subparts. Thank you so much for watching the video. If you haven't subscribed my channel yet, do subscribe it for all the notifications. Thank you. I'll see you in my next video.